Welcome to the deep dive. Today we're tackling a really fascinating subject, artificial intelligence.
hmm
Specifically, how AI is starting to reshape, well, architecture and our cities.
Yeah, the built environment.
Exactly. We've gone through a really interesting new book, quite critical, actually, and also a playbook for cities looking to use AI.
Right, a practical guide.
And we know you, our listener, want to get a solid handle on this stuff quickly without getting bogged down in, overly technical details.
So consider this your quick route to the key insight.
That's the plan. Your
Mm.
streamlined guide.
And what really jumps out from these sources, I think, is this kind of contrast in speed.
How so?
Well, the book points out something pretty surprising. Architecture, construction, they've been comparatively slow adopting AI
Slow compared to what?
compared to other creative fields, even other industries that were looking at machine learning way back like in the 1980s.
The 80s. Wow. Okay. That is a lag.
Yeah. And the book suggests that the AI tools we're seeing now in architecture, they're mostly just scratching the surface.
So marginal improvements, not revolutionary change.
Pretty much. That's
No.
the argument.
Okay. Let's dig into that. This slow adoption. Yeah. Why do you think that is? Or what does the book say?
Well, the book argues that the early AI efforts, and even some current ones, often use things like Jan's general adversarial networks.
We'll circle back to what those are, yeah.
Definitely. And supervised learning. These approaches, they just haven't really hit the mark,
Hit the mark for what specifically?
particularly for what the book calls the architecture of 90%.
The architecture of 90%? What's that?
It's basically the everyday stuff, the more standardized production-focused building design that, makes up most construction, not the flashy one-off projects.
Right. The bread and butter building work.
Exactly. And the insight is that those earlier AI methods just weren't well suited to the complexities and sort of practical nature of that kind of design.
So, okay. We see maybe some cool AI concept images online.
Right, eye candy sometimes.
But the actual process of designing the office building down the street or a housing development, that hasn't really been transformed by AI.
That's the core argument about where things stand now. But, and this is crucial, it's not saying it can't change.
Okay, so it's not a dead end.
Not at all. This is where it gets really interesting. The book highlights recent progress in, understanding the brain, biophysics.
Neuroscience feeding into AI.
Exactly. That, plus advances in computer science, handling 3D data, VR, that kind of thing, and new architectural theories, it's all creating a much better foundation.
A more fertile ground for AI to actually make a difference.
Precisely. The limitation wasn't necessarily AI itself, but maybe the type of AI used and how it was applied without fully grasping architectural thinking.
So the slow start was maybe just waiting for the right ingredients to come together, the right tech, the right understanding.
That seems to be the perspective.
What kind of AI techniques does the book see as more promising then?
It points towards a shift away from those earlier methods. Things like reinforcement learning from human feedback.
Okay, what's that? Learning from guidance.
Yeah, the AI learns by trying things and getting feedback, like a reward or correction. Also, imitation-based learning.
Imitation, like learning by watching.
Exactly, watching experts. Plus, self-learning systems and transfer learning using knowledge from one task for another related one.
That imitation learning, that sounds really relevant. Architecture has that traditional apprenticeship model, right?
It really does, and the book uses this analogy like AI robotics. Imagine CAD software.
Like AutoCAD or Revit.
Yeah. Imagine that software as the environment where an AI assistant learns directly from watching a human architect design.
Okay, that's a powerful image.
Yeah.
The AI as an apprentice in the digital space.
It is, because it focuses not just on the final thing, the building, but on the process, how it gets designed. The book calls it how things come to existence.
I like that. It feels much closer to how designers actually think and work, doesn't it? It's iterative.
It absolutely does, much more intuitive.
So where does the book see these newer AI approaches being most useful? What are the strategic fields?
It lists several key areas. Reverse prompting, for instance.
Reverse prompting, like AI helping define the problem better.
Sort of, yeah. Helping clarify design goals. Then there's AI-powered research. Imagine AI digging through vast amounts of data to find relevant precedents or technical solutions.
Okay, that makes sense. What else?
Generating initial design patterns, like for massing studies or early layouts. And providing support during design development, the book calls it advice whispering.
Advice whispering. I love that phrase. It suggests collaboration, not replacement.
Exactly. Like having a super knowledgeable assistant looking over your shoulder, offering suggestions or flagging potential issues.
So AI handles some of the heavy lifting, the analysis.
Right. Continuous assessment of performance, structural, energy, costs, etc. Automated design reviews. Even helping evaluate different design options more objectively.
It sounds like it could free up architects to focus more on the creative vision, the human side of
Well,
things.
that's definitely the potential upside. But there's a caveat.
Oh,
The computational power needed, especially for architecture, because it's inherently 3D. It's spatially complex.
right. Not just flat images or text.
Exactly. And the book suggests that really unlocking this potential, especially with complex spatial AI, might depend on breakthroughs in computing tech itself. Things designed for 3D, maybe even like ternary semiconductors or spatial computing.
Okay, so hardware might be a bottleneck too.
Interesting.
Right, so we got a picture of where AI in architecture is and where it might go. Let's maybe clarify some of these AI concepts for everyone. Our sources mention quite a few terms.
Good idea. So machine learning, at its core, is about algorithms learning from data. They build models to make predictions or decisions without being explicitly programmed for every single possibility.
Learning by example, essentially.
In a way, yes, and there are different styles. Supervised learning is like teaching a kid flashcards. You show it labeled examples, this is a door, this is a window, and it learns to recognize them.
Okay.
Unsupervised learning is more like giving it a huge box of photos and asking it to sort them into piles that make sense without telling it what the piles should be. It finds patterns on its own.
And reinforcement learning, you mentioned that earlier, is promising.
Right. Think of an AI agent, maybe like a little virtual robot, in an environment, say, designing a floor plan. It tries an action, like moving a wall.
Okay.
If that action leads to a better outcome according to some defined goal, maybe better circulation, more light, it gets a reward. If it makes things worse, a penalty.
Yeah.
Over time, it learns a strategy, a policy to get the most rewards.
Learning by trial and error with feedback.
Exactly.
Now, the book really pushed imitation-based learning. Why is that seen as such a good fit for architecture?
Well, like we said, it mirrors that apprenticeship idea. It learns from watching experts, architects designing. The sources say it can be more efficient, maybe safer than just letting an AI explore randomly, especially in complex design spaces. And critically, it can learn subtle things, nuances that are really hard to write down as explicit rules.
Things an experienced architect just knows how to do.
Precisely. It's learning the how by watching, not just the what.
So instead of trying to feed it every rule in the building code plus design theory,
Which would be incredibly difficult.
it learns by observing successful design processes.
What are some specific techniques here? You mentioned JANs earlier, but what about for imitation?
So within imitation learning, there's behavior cloning. That's kind of the direct approach.
Yeah.
The AI tries to mimic the expert's exact action for a given situation.
Okay, simple copying.
A sophisticated version of it, yeah.
Yeah.
Then there's inverse reinforcement learning, or IRL. That's more advanced. It tries to figure out the goal the expert was trying to achieve, the underlying reward function that explains their actions.
Ah, understanding the why behind the what's. Exactly. And then you get into even more advanced stuff like adversarial imitation learning AL, often used in robotics, where it learns robust behaviors by trying to fool a discriminator, similar to JANs, but for actions.
The source is also flagged augmented behavioral cloning and transfer learning.
Right. Augmented behavioral cloning uses things like attention mechanisms, ways for the AI to focus on the most relevant parts of the observation to learn more effectively.
Got it.
And transfer learning, we touched on this, it's super important. Take a model trained on millions of general images. It already understands edges, textures, basic shapes.
Okay.
You can then fine-tune that model on a smaller set of specifically architectural data. It learns faster and needs less architecture-specific data because it's transferring its general visual knowledge. Huge for efficiency, especially for that architecture of 90%.
Makes sense. Saves starting from scratch every time.
Yeah.
The outline also mentions, let's see, open-ended machine learning. Tree of thoughts.
Yeah, open-ended ML is kind of the frontier AI systems that can invent their own goals and tasks, constantly learning and adapting. Very ambitious.
And tree of thoughts.
That's more about structured problem solving. Imagine the AI exploring multiple possible steps or lines of reasoning, like branches of a tree. It evaluates each path, maybe backtracks if one isn't working. It's a way to get more strategic thinking.
Like weighing different design options mentally.
I'll say it like that, yeah. And that's an older but very efficient algorithm for finding the best path, like for routing things, though apparently not much used in design tools yet.
Okay. And these other reinforcement learning strategies. Observe and look further. First return and then explore. They sound quite sophisticated.
They are. They're ways to help the AI explore its options intelligently, especially when the rewards or feedback are delayed or hard to find, balancing trying new things versus sticking with what works.
Self-supervised learning also came up. How's that different?
Self-supervised learning is really powerful. The AI learns from unlabeled data vast amounts of it by making up its own tasks.
How does it do that?
For example, it might take an image, hide a patch, and then try to predict the missing patch. Or take sentences and predict the next word. It generates its own labels from the data itself.
Ah, so it doesn't need humans labeling everything.
Exactly. That's a huge advantage. It can lead to better generalization, use data more efficiently, and sometimes be more stable to train than reinforcement learning.
Got it. And quickly, backpropagation.
Yeah.
Discriminative versus generative AI.
Backpropagation is just the core mathematical technique used to train most neural networks how they adjust their internal connections to learn.
Okay, the learning mechanism.
Right. And discriminative AI is about classification or identification. Is this a chair or a table? Generative AI is about creating something new, generate an image of a chair, generate a floor plan. Often they work together.
Right. And Jan's generative adversarial networks, you mentioned them earlier, they're generative.
Yes. They typically have two parts. A generator creating fake data and a discriminator trying to spot the fakes. They learn by competing against each other.
The adversarial part.
Exactly. They can be self-learning in a sense, but they have issues sometimes. They get stuck generating the same thing, or they're unstable, or the results aren't quite coherent. Computational cost is also high.
And diffusion models are seen as an improvement.
Yes, generally. Models like Stable Diffusion, Midjourney uses them. They tend to be more stable to train and often produce higher quality, more coherent images than many GANs. They work differently by learning to reverse a process of adding noise.
Okay, that's a helpful overview of the techniques. Now, what about the structures, the neural network architectures themselves, especially for imitation learning?
Right, so autoregressive networks are common. They generate things step by step, sequentially, like predicting the next word in a sentence or the next design action based on previous ones. Very natural for imitation.
Makes sense.
Then there are architectures inspired more directly by the brain, like these dual neural circuit policy networks mentioned. The idea is to mimic some aspects of human neural pathways to hopefully get better generalization, applying learned skills to new, unseen situations.
And the internal layers of these networks actually learn meaningful things.
Research suggests yes. The hidden layers in these imitation models can develop internal representations that capture important aspects of the task. They're not just black boxes, they're learning useful abstractions.
Fascinating. It really feels like AI is borrowing more and more from how we think. Speaking of which, large language models, LLMs, ChatGPT, and the like, they feature too.
Absolutely. ChatGPT, Claude, Mistral, they're trained on huge data sets of text and code. Many use reinforcement learning with human feedback, RLHF, where people rank the AI's responses to guide it.
Guiding it towards being helpful and safe.
Right. Or techniques like constitutional AI, where it follows a set of principles. They're incredibly capable at reasoning, translation, coding, and we're seeing a trend towards smaller versions you can run locally on your own computer.
For privacy, presumably.
Yeah, data privacy is a big driver there.
Okay. And AI isn't just in labs, right? The sources give examples of it out in the world.
Definitely. Game developers have used procedural generation, a form of generative algorithm, for ages to build game worlds.
They're creating environments.
Fashion uses AI like LaLaLand.ai, creating virtual models. Finance uses it for automation, fraud detection. And a key skill emerging is prompting.
Telling the AI what you want, effectively.
Exactly. Then there's specific tools like Musavir.ai for rendering, My Avatar for hairstyles. And Devin, this new AI software engineer, seems like a big step in autonomous coding.
These examples really bring it home. The sources also mention some historical AI milestones.
Yeah, quick context. AlexNet, in 2012, huge leap in image recognition, really kickstarted the deep learning boom.
Okay.
IBM's Deep Blue beating Kasparov in chess used massive search and evaluation functions, partly based on human games, so a form of imitation there too.
Right.
DeepMind's AlphaGo beating the Go world champion, that was a big deal because it learned complex strategy using deep neural networks, going beyond human knowledge in some ways.
And AlphaGo Zero.
Even more impressive, it learned entirely from self-play. No human game data needed, just the rules. It surpassed all previous versions. shows the power of self-learning.
Incredible progress.
Huh.
But it's not all smooth sailing. The sources raise serious challenges and concerns, too,
Oh, definitely. The black box problem is huge. We often don't fully understand how these complex models reach their conclusions.
which makes them hard to trust or debug.
Exactly, and vulnerable. They can be attacked, their training data can be poisoned to introduce biases or errors.
And the hallucinations, LLMs making things up.
Yeah, the analogy uses their blurred JPEGs of their training data. They reproduce patterns, sometimes nonsensically, without real understanding. Lack of transparency is key there too.
Then there are the bigger societal questions. Will AI surpass human intelligence? The ethics of military AI.
The whole Oppenheimer moment
Yeah.
discussion. Yeah, and you have figures like Elon Musk raising alarms.
Right.
Plus more immediate worries. AI enabling cybercrime, like sophisticated tax fraud schemes, or misuse of AI video generators for deepfakes.
Scary stuff. Is anything being done? Regulation.
There are efforts. The EU AI Act is a major one. US-China talks on AI safety. International agreements are being discussed, but it's complex and global.
And lawsuits.
Lots of those. The New York Times suing OpenAI over copyright. Artists suing image generators. Elon Musk suing OpenAI over its original mission. It highlights the legal and ethical minefields versus challenging OpenAI's charter, too.
Wow. Okay, so a lot of tension alongside the excitement, which brings us to the huge expectations and the economic side.
Massive expectations. You hear it at Davos, everywhere. AI is seen as transformative for healthcare, education, the whole economy.
Right.
The IMF thinks it could redraw the world economic map with big impacts on jobs, both creation and displacement.
And tech leaders are worried about scaling it.
Sam Altman, OpenAI CEO, has talked about hardware shortages, needing more chips, more power to keep scaling AI up. He's looking at investing billions in chip manufacturing.
Billions. The investment is huge then.
Enormous. Corporations, governments, and AI startups are getting astronomical valuations. Look at the market cap of the big tech companies, Magnificent Seven. A lot of that is driven by AI hype.
Is there a risk of a bubble?
Some economists definitely warn about that. A need to diversify AI applications beyond just, say, chatbots.
Okay, so massive economic forces at play. Let's pull back to architecture again. How is AI actually showing up in tools architects use now?
We're seeing it. Autodesk Forma used to be called SpaceMaker, uses AI for early-stage site analysis, feasibility studies.
Okay, practical analysis tools.
Yeah, and research like Philip Basola's work, Kyle Steinfeld's, Jan Lose exploring AI for site-specific design ideas, applications like Sketch-to-Pix turning sketches into renders.
So the tools to augment the process.
Right. Even big firms like Morphosis, Foster Plus Partners, they have R&D teams experimenting, trying to blend AI analysis with human intuition. Carlos Bannon's work using Midjourney, Stable Diffusion as design assistants is another example, though he notes the challenge of keeping craftsmanship alive.
But the sources, particularly the book, seem critical of these current approaches. They talk about poiesis.
Yes, the book really emphasizes this idea. Poiesis, the Greek concept of bringing something new into being, true creation. It argues that authentic architectural creativity starts before you get to the parameters in CAD or the data fed to current AI.
Before the quantifiable stuff.
Exactly. And it sees a disconnect. AI research is moving fast, but architectural applications seem stuck using older methods like supervised learning or basic GANs for things like layouts.
While other fields are using reinforcement learning, imitation learning.
Right. Like autonomous driving, robotics. They've had more success with those advanced techniques. The book suggests a design robot learning within a CAD or VR environment could be more fruitful.
And it implies some current research isn't that practical yet.
It notes that some early AI explorations, while interesting, might not yet outperform an experienced architect sketching ideas by hand in terms of speed or quality for initial concepts.
This leads into that deeper philosophical point about the poetic nature of architecture versus AI. Heidegger's ideas.
Yeah, the book draws on Heidegger to argue that real creation, poiesis, needs consciousness, intention, a deep understanding of context and being. Algorithms based on math and patterns.
They lack that spark.
They lack the prior knowledge, the lived experience, the intentionality for that kind of creativity. Architecture is tied to human consciousness, how we dwell in the world. AI, the book suggests, is currently more like a superb typist, great at manipulating symbols based on patterns.
But not generating meaning.
Not originating meaning or true creative narrative in the human sense. GPT generates text based on probabilities learned from trillions of words. The book calls this usuality, following common patterns not from genuine intelligence or the kind of disruptive thinking that marks human breakthroughs.
Which brings us to AGI, artificial general intelligence. Is that the goal?
AGI is framed as something way beyond current generative models. The book suggests achieving it might need new paradigms, maybe moving past the very foundations of current neural networks, like the McCulloch-Pitts model.
So a fundamental shift might be needed.
Potentially. Companies like Versus are proposing alternatives inspired by neuroscience ideas like active reference, distributed intelligence, aiming for maybe smaller, more efficient, but more capable AI.
Distributed intelligence, decentralized AI.
Yes, spreading the processing across many nodes or having more autonomous agents. Imad Mustak, formerly of Stability AI, is a big proponent of decentralized AI.
So the future of AI might not just be bigger versions of what we have now.
It might involve entirely different architectures and principles.
And thinking about the whole AEC ecosystem, architecture, engineering, construction, it's not just architects.
Exactly. It involves so many disciplines: science, social science, engineering, art. And the book stresses how hard it is to capture the qualitative stuff, feelings, atmosphere, cultural meaning in algorithms and data sets.
The poiesis again?
Right. Authentic creativity, it argues, comes from that deeper place, not just algorithms trained on limited data.
But there's hope in looking at the brain, right? Neuroscience.
Yeah.
You mentioned Jeff Hawkins' Numenta.
Yes. The book contrasts the old McCulloch-Pitts neuron model with current neuroscience, particularly Hawkins' work on the neocortex and its column structure.
What's the key takeaway from that?
The neocortex learns models of the world, objects, concepts spatially and over time. It learns through movement and perception, constantly updating. It integrates senses, distributes knowledge. It runs on a kind of simulation or internal model of reality.
Wow. So our brain builds a predictive model of the world.
Essentially, yes,
Yeah.
based on sensory input and movement. Understanding how it does that, the role of spatial models, reference frames, continuous learning is crucial. The big question is, how do we build AI based on those principles?
It feels like AI might be hitting a wall with current approaches, needing new inspiration.
The book suggests it might be like physics before quantum mechanics or relativity needing a paradigm shift to answer new questions.
In all this computation, the environmental cost is huge, isn't it?
It's massive and growing fast. AI's energy consumption is skyrocketing, potentially exceeding cryptocurrency mining soon.
Oof. What's being done?
People are working on efficient models, better hardware, green data centers, trying to measure the footprint. But the demand is huge. The U.S. government is talking to tech firms about needing more electricity generation just for AI.
It's a whole energy-hungry ecosystem, GPUs, servers, networking.
Exactly. Though there are potential solutions, things like ternary semiconductors, BitNet B1.58 is an example, might offer much better performance per watt.
And quantum computing.
Long-term potential for certain problems, but still faces big technical challenges. Might be leapfrogged by other things like optical neural nets. And again, Versus biologically inspired approach aims for efficiency too.
Okay. This brings up that super-paired idea again and the economics.
Yeah, Tomas Mikolov, a respected AI researcher, called LLMs super parrots, brilliant at repeating and remixing learned patterns, but the quality depends entirely on the data, the algorithm, the compute power.
And the money flows towards AI.
Disproportionately so compared to, say, architecture, R&D, or real estate development itself. The financial incentives are heavily weighted towards AI right now.
But architecture is fundamental.
Absolutely. Carlota Perez, the economist, argues we need to see AI in that broader context of technological revolutions, where infrastructure, the built world, is key. AI is part of the ongoing ICT revolution, and she stresses needing public policy to shape it for inclusive benefit.
So given all this, what are the proposed new ways forward for AI in architectural design?
The book really pushes for new types of imitation-based and self-learning AI focused on the design process itself.
Learning how architects design, not just what they design.
Exactly. Looking at two kinds of patterns. The patterns in existing solutions, yes, but more importantly, the patterns in the process of creating them.
Why the focus on process?
Because just mimicking existing buildings needs vast databases and huge computing power. But focusing on production architecture, where designs often share similarities, AI could learn the typical steps, the decision-making processes, and help bridge gaps or suggest variations.
Applying lessons from robotics and other fields.
Yes. There's a whole world of advanced AI models from robotics that haven't really been tapped for architecture yet. using CAD or BIM software or platforms like Wearkesho as the robot body.
Steered by these advanced AI models.
Right. Imagine every architect having an AI assistant learning alongside them, tackling design challenges together, using specific machine learning strategies or SMLs.
So the key is bridging the gap between architects and AI researchers.
Critically, focusing on the poetic nature of design, the making process, integrating 3D spatiality and time, using VR and spatial computing, informed by new brain theories. It's about a deeper integration.
Maybe even questioning the limits of current AI paradigms.
Yes, and exploring alternatives. The book ends on this idea of a potential singularity, not AI taking over, but an intertwining of human thought, AI, immersive tech, and architecture, all based on spatial understanding.
We mentioned some specific tools and companies earlier: Stable Diffusion, Midjourney, Devon, OpenAI, DeepMind.
Right, and milestones like AlexNet, AlphaGo, research areas like imitation learning, RL, generative AI, and for cities, things like the Smart Cities mission, Data Smart Cities strategies.
And the need for ethical AI principles in cities. Evaluation frameworks like TAMDF.
Crucially, citizen engagement, too, making sure AI serves the community.
Okay, so wrapping up this really comprehensive deep dive, it seems the story is one of slower adoption in architecture in cities so far,
Compared to the hype, maybe, yeah.
but immense potential if we leverage these newer, more sophisticated AI techniques, especially those inspired by how humans learn and think spatially.
Absolutely. We hope this discussion has given you, our listener, a solid overview of where things are, the key concepts, and what might be coming next.
And building on that, here's a final thought for you to consider. Architecture and city development are this unique mix of creativity, practicality, and human experience. So thinking about that mix, what specific part of this world do you think is most ready for a genuine AI revolution? And, perhaps more importantly, what ethical guardrails absolutely must be in place as we implement it to ensure it genuinely improves our lives in the places we build and inhabit?
Definitely something to think about.
We encourage you to explore the sources we've discussed and keep questioning this evolving relationship between AI and our world. Thanks for joining us on the Deep Dive.